Hello, we are group number 11, also known as B1RD, Bird, and this is our final project for the Mars landing. Our quick overview, we're going to go through some introductions, backgrounds, and requirements, as well as our final design, our manufacturing, as well as test results, and finally our conclusion. Now, who is Bird? First, we have Caden Fields, our construction manager number 1, then Kevin Fisher, our test and verification manager. We'll have Isole Jordan, our other construction manager, and then there's me, Joe Pinto. I am your project manager. This is our RFP provided by NASA. It gives us all our background and as well as requests for the proposal. Some of their customer requirements provides that the Mars lander shall deliver each astronaut to the surface of Mars. Mars lander performance shall be demonstrated during video recording tests on launch day, as well as carry 2 pilots, which are eggs, and the lander needs to be reusable. We were also given contractor requirements. The lander needs to demonstrate a survivability on impact of a 12-foot drop, as well as protecting the 2 eggs from damage weighing up to 59 grams each. The demonstration vehicle shall fall upon hard tile for its tests, as well as be built on the same construction day as competitors with all the proper functions set. Now, the vehicle needs to house these 2 eggs without being able to eject any of them, and it needs to have all of its capabilities on the same day as all the rest of the competitors. And it needs to be able to be demonstrated in 2 separate demonstrations in order to show the reusability of the product.
Okay, for this, for our final design, we chose to go with 2 parachutes to even out the weight distribution that we had throughout the aircraft. We used marshmallows and cotton balls to cushion the inside so that our pilots would be nice and safe. We used straws as shock absorbers so that it would kind of soften the impact of our fall when we threw our aircraft off of the ledge. And we also used cardboard, plastic straws, cotton balls, marshmallows, string, rubber bands, and plastic bags for our aircraft. Here it is again laid out for all of them. We use the rubber bands as a fastening mechanism to close our box. So our initial idea was to fold our box or fold the cardboard that we were allowed to have into a box, separate the box with cardboard so that our pilots would have their own separate cubby. Cut some straws in half to again use them as a shock absorbers, which we ended up doing. Take 4 marshmallows on the side so that we could have shock absorbers on the side of the box as well as at the bottom. Put string through the bag so that we have parachutes. Fill the box with cotton balls to cushion it, and add the eggs inside the box and tape the boxes closed.
So the changes that we made to our project, all soft material was placed inside the box instead of the marshmallows being placed on the outside of the box. The box was fastened shut with rubber bands and 2 straws punctured through the box. Parachutes were secured to the flaps on the box rather than the main structure. The compartment holding the pilots were not separated. We only had 1 inside compartment. The straw legs were secured with marshmallows, and a pre-made box was used instead of an unused piece of cardboard. So the challenges that we faced, we actually didn't have enough time to secure the marshmallows to the outside of the craft with glue, and tape wouldn't have been secure enough. We were also unaware that we needed to load and unload our test subjects for each test, and we were only prepared to open the box once. Now, because we had to open the box multiple times as quickly as possible, securing the parachutes to a fully closed box with 4 flaps wouldn't have been efficient. We also did not have enough cardboard available to make separate compartments, and we did not have enough time to secure the straws to the craft with glue, and tape also wouldn't have been secure enough. So here we have our side, the top, and the front views of our lander.
When we actually got to the test phase, we actually went through 3 trials. The first 2 were from a height of 12 feet, and the last one from a height of 3 stories tall, approximately 36 feet. The loading times was about 32 seconds, give or take, on each of the 3 trials, and the record unload time was 8 seconds. All three of the trials did not change the dimensions of the lander at all. They remained the same throughout. And by the end of each trial, we considered it a success because the pilots received no harm. If you follow these links, you'll be able to see videos of the first two trials, both of which, again, were successful. As you can see in this one, we had to raise the landers over the 12-foot mark and then drop them over. We did have a little bit of trouble doing that, but we did eventually get it over the side, and the pilots did survive without any harm at all. In just a moment, you'll see that. And there you go. The pilots, after we examined the box, made it without harm. And the second video will show you pretty much the exact same thing. Maybe with just a little bit more difficulty, but the lander performed well. And yeah, there you go. The lander went over the side, and it made it just fine. The pilots received, again, no harm. And this is the final picture of our lander after the three trials were over, as well as the pictures of our two pilots, Phil and Finn. Again, Phil and Finn survived, no harm whatsoever, and then the lander only received minimal damage to the landing gear, but not the actual body or main part of the lander.
Our final design for our lander was a small cardboard box filled with cotton balls. We attached 2 of the grocery bags to each part with string, as well as sticking bendy straws on the bottom to act as shock absorbers, connecting them to the box with marshmallows within inside. The design process was kind of fun. We specifically wanted to decide we wanted to have shock absorbers, parachutes, interior cushions, and 1 manual lock on the outside to keep the flaps closed. During the assembly, we specifically assigned each person to do one specific task to put it together. Caden and Kevin were attaching the grocery bags to the flaps using the string, while Mojave Soleil and I were sticking the straws inside the box in order to make a manual lock, as well as make the shock absorbers on the bottom. Our final test results ended as a wonderful success for each trial, only having a few bits of damage by the shock absorbers on all the landing gear, as it was not reusable. However, each time we were able to do successfully, and only after the third one did the damage really seem to take a toll on the lander as a whole. If we were to redesign this specific lander, we would probably make sure the landing gear would be a little bit stronger and more reusable. As we've mentioned multiple times, it did not survive more than 3 different trials. And that is the end of our presentation. Thank you very much for having us. Have a good day.